Hello students, in this lecture we will see the fifth numerical on nodal analysis. The problem statement is find the current through 10 ohm resistor using nodal analysis. So first step is identification of node. Node, it is the junction where more than two elements are connected. So this is the first node. I will denote the voltage at this point as Vx. The second node is over here and we will denote the voltage at this point as Vy. And the third node is over here and one can treat this as a reference node. So this is my reference node. Now I will find out these two voltages by applying KCL at these nodes. So KCL at node X, summation of outgoing current is equal to summation of incoming current. Now you check, is there any current source connected to node X? No. So we'll assume all the currents as outgoing. So this leftward current, outgoing current, can be written as Vx. As you progress, you have a leading sign minus, so Vx minus 5. You reach to reference node, so minus 0 divided by 6. Plus this downward current can be written as Vx minus 0. You reach at reference node divided by 4. Plus the rightward current can be mentioned as Vx plus 2 minus Vy and divide by 10. This is equal to 0, no incoming current. LCM over here is 60, so I will multiply by 60 throughout, so I will get 10 Vx minus 50 plus 15 Vx plus 6 Vx plus 12 minus 6 Vy is equal to 0. I have multiplied throughout by 60. So this will give me equation as 31 Vx minus 6 Vy is equal to 38. And this is my equation number 1. I require one more equation over here. So now I will apply KCL at node Y. Whenever you write down KCL, the next line you have to write down summation of outgoing current is equal to summation of incoming current. Is there any current source connected to node Y? No. That means you can assume all the currents as outgoing. The leftward current can be mentioned as Vy minus 2 and then you reach at node X, so minus Vx divided by the resistance in this path, that is 10, plus the downward current is Vy minus 0 by 15 and the rightward current up to the reference node can be written as Vy minus 20 divided by 5 is equal to 0. Now LCM over here is 30. So I will multiply throughout by 30. So I will get 3 Vy minus 6 minus 3 Vx plus 2 Vy plus 6 Vy minus 120 is equal to 0. So in equation format this turns out to be minus 3 Vx plus 11 Vy is equal to 126. And this is my equation number 2. So there are two unknowns and we have found out two equations. So we will solve them simultaneously and you have to obtain the value of Vx and Vy. So Vx turns out to be 3.63 volt and Vy turns out to be 12.44 volt. But the problem is not over yet. You have to calculate current through 10 ohm resistor and 10 ohm resistor is over here. So current through 10 ohm resistor. Now you decide how you have to move. Node X to Y or Y to X. If you have decided to move from X to Y, then you have current as Vx plus 2 minus Vy by 10. That means the current is moving towards right. I will substitute the value over here. So it will be 3.63 plus 2 minus 12.44 divided by 10. And the current is moving towards right. So this will give me answer as minus 0.681 ampere towards right. So one can make the numerical value as positive by changing the direction. So current through 10 ohm is 0.681 ampere towards left. If I would have selected initially the current towards node X from Y, then I could have obtained Vy minus 2 minus Vx by 10, but ultimately I will get 0.681 ampere. So that is all about this numerical. Thank you.